A very good evening to all of you, and good evening to all those who are attending this session from India. Good afternoon to those who are attending it from Germany, especially friends of Professor Bansal. I'm told few of them are there. And good morning to those who are attending from USA and Canada, especially the three wonderful daughters of Professor Bansal, Pooja, Shalu, and Shweta, who are there with us in this session. I welcome you all for this first Professor N.K. Bansal Memorial Lecture. Professor Bansal was the guru for all of us and for countless number of professionals and academicians and researchers across the globe. And to commemorate his contributions in the field of energy and in career making for all of us, we are organizing this Professor N.K. Bansal Memorial Lecture Series, and the first one is today on the day of his birthday. So actually, today is the day of birthday of Professor N.K. Bansal, and we are organizing this memorial lecture to remember him and for his wonderful contributions to the world of energy. So without taking much time, we are having Professor Ajay Mathur as the speaker for the day. But before we have his presentation, we also have Professor K. Subramanian, who's head of the Center for Energy Studies at IIT Delhi, where Professor Bansal had spent a large part of his professional career. We also have Professor T.C. Kandpal, who has been who is guru for all of us, and who has been kind of hand-holding all of us for doing this kind of event in sweet memories of Professor Bansal. He has been a colleague with Professor Bansal also, and as part of this session, first of all, I would request Professor K. Subramanian to kindly brief us about his role, what was his role in the Center for Energy, because I think he was kind of from the beginning of the Center for Energy with Professor Soda and all of the stalwarts we had. And then we would also request Professor Kandpal to share his memories and experiences with Professor Bansal. Over to you, Professor Subramanian, please.
Thanks, Professor Ajay Mathur. Chief guest, Professor Ajay Mathur, Director General TERI, and Professor C. Kandpal, Deputy Director Operation, IIT Delhi, and Professor Jyotirmay Mathur, and Professor Visalgar, and our colleagues and other expert members joining here. First of all, we thank Professor Ajay Mathur for inviting us and organizing this memorial lecture on behalf of late Professor N.K. Bansal. Professor Bansal joined in CES in the year 1979, IIT Delhi. His research area include energy efficiency in buildings and energy economics and renewable energy. And now today CES has grown with his contribution, and we have now faculty member 24, and we have 101 PhD scholars and 120 MTech students. And he guided several PhD, MTech, and he published more than 350 papers in reputed journals. And he has received of the so many awards and the fellowship, Alexander I Humboldt Fellowship, and he received prestigious awards such as Jacob Gold Medals and Pioneer in Renewable Energy, Solar Pioneer from India, Lifetime Achievement Award, and so on. And he served as the Vice Chancellor of Sri Mata Vaishnav Devi University, Jammu and Kashmir, and he was head of Center for Energy Studies in the year 1999. And Professor Bansal is well known for his integrity, hard work, and contributions in the field of energy. And Professor N.K. Bansal is no more with us, but his contributions to this area, including energy, would always live with us. With this word, again, thank you all, sir. Yeah, I now thank you very much for giving opportunities.
Thank you, Professor Subramanian. I request Professor Kandpal, sir.
Yeah. Thank you, Professor Mathur. You know, Dr. Ajay Mathur, Director General TERI, Professor Subramanian, distinguished participants and friends and family members across the world of Professor Bansal, Jyotirmay, Vishal, and other students of Professor Mathur. I mean, that's the way I usually talk to them. It's indeed a pleasure to be a part of this first memorial lecture, for Professor N.K. Bansal. Whatever inputs Professor Subramanian has already given, I just would like to say a few things about him, because I have had the privilege of knowing Professor N.K. Bansal since he joined back. He had his PhD also from IIT Delhi, but he joined back as a lecturer in Center for Energy Studies in 1979. And at that point in time, I was doing research, for 2 years in certain area, and we had some overlap, but not as much. And since then, till he joined Sri Mata Vaishno Devi University as Vice Chancellor, we have had the very close interaction in so many different respects. So what I'll do, I'll quickly try to share what I observed in Professor N.K. Bansal as a colleague, as a researcher, as a human being, and so on. So I'll tell you quickly one by one that one of the things that he was extremely hardworking and very, very productive. I mean, I remember that for one of these series of renewable reviews and renewable resources, we needed some articles were to be prepared. Everything was in press, and at the last moment, with one of the publications, some problem came, some copyright problem. So we had to prepare an article in a week's time, and we looked forward for a contributor. Professor Soda said, no, nobody else can do that. It's only Professor Bansal who would do a quality job in such a short period of time. And indeed, he wrote that, and that was in fact the first article of that particular volume, because Professor Soda said, no, now let it be the first one. And I'm just giving you what he could do. The next thing is that he was very, very helping in nature. And again, my own experience that I had to go for the first time abroad on 2 days notice to University of Florida for some short meetings. And I had no time those days. Getting foreign currency was used to be a headache. So I told Professor Bansal that, Dr. Saab, this is the problem I'm facing. He said, Ghar chalo. And I went along with him. He had a few American Express traveler checks and some marks and some dollars. Well, when you come back, please give it back to me. So that's how, I mean, just that you tell him the problem, he'll have a solution. The third very important characteristic, and I wish I could emulate that, was that he was ready to acquire knowledge and skills from anybody, anywhere. If he knows that somebody. So as I told you, I was a research scholar, and he was a faculty. But at some point in time, for plastic solar collectors, he needed to know the nitty-gritty of optics of solar collectors, which I was doing as a PhD student. So I still remember he came to my lab with a piece of paper and asked, Kandpal, kaise hota hai? How do you do this ray tracing and other things? And I know later on he used it also. So he won't have anybody, any person, if he knows that he has to pick up any input, he would not hesitate. No air around that, right? The next thing is, of course, the testimonies, the students here. He was a very good mentor for his students. Some of the students are not here today, but whether it is Mahavir Bhandari, whether it is Pranay Pratap Kohli, whether it is what is his name, Singh, anyway, I'm forgetting the first name now. Who works with PwC, I think, right?
Indrajit, sir.
Indrajit, yeah, great. Thanks, Jyotirmay. So what I'm saying is that very, very good mentor, and he will go out of the way to groom them, provide them the best facility, and I am sure Vishal and Jyotirmay watch for it. The another aspect is his ability to diversify into different areas. See, as everybody said today, that he worked in energy efficiency, but let me tell you, he started with the periodic theory, applications in for solar passive buildings, and he has a book co-authored with several other people with Bergman, right? A very, very well-known book, and a lot of other things in that area. But then he ventured into energy planning. In fact, he was the first one to bring Markal into IIT Delhi to use it for policy planning purposes. He guided Kamal Rizal, a Nepali student, on that. And then he had he was the first one to bring a 25 kilowatt photovoltaic roof in IIT Delhi way back when the DESU those days did not allow us to connect it to the grid, right, at that point in time. So and he had a lot of other work on photovoltaic. So you can see, and he himself, his basic grooming was on nuclear energy. So you can see his ability to diversify and also to contribute into all these different areas, right? So as I said, the list can go on very long, but I know the time is limited. But as I said, that it was real pleasure and privilege to work with Professor Bansal and interact in so many different ways, so many different capacities. Just to add one more, that single-handedly he could revise our evening MTech program within a period of 2 weeks and get it, approved through all stages in the institute, or just single-handedly. That was NK Bansal, right? I'm saying that's what he could do. Now, to end, it's a real privilege to have Dr. Ajay Mathur with us for this first, memorial lecture for NK Bansal. We could not have had a better person who has really changed the way energy efficiency works in India, and started so many interesting initiatives, which we really very thankful to him. So as I said, the best person we could have ever thought of for this memorial lecture. And just to say that my interaction with him started, I don't know whether he still remembers or not, with SESI. I was asked to edit these, do something SESI journals, that whether I could revive that. I miserably failed, but I still got a lot of help and support from Dr. Ajay Mathur, and since then we have been interacting in all different fora. So it's really a pleasure and privilege to welcome Dr. Mathur for the first memorial lecture. Thank you so much.
Thank you very much, sir, for sharing your memories and experiences with Professor Bansal. And you have already introduced our speaker of the day, Dr. Ajay Mathur, who has, in addition to bringing energy efficiency in the forefront in the country, whether it is through star labeling or ECBC or PAT or whatever, countless number of initiatives are there in his credit. He has also led India in climate change related negotiations. I am just mentioning it for information of those who are from the family side, because they might not have professionally interacted with Professor Ajay Mathur. Otherwise, anybody and everybody in the country who even knows E of energy knows Professor Ajay Mathur very well. Over to you, sir, please.
Namaskar. Thank you very much. I consider it a huge honor to be asked to deliver the first memorial lecture in the memory of a great man, Professor N.K. Bansal. Professor Bansal, I interacted with him for many, many, many years. Like Professor Kandpal, I also met him first in dealing with the Solar Energy Society of India. But over the years, particularly his work on passive buildings is something that made him the person to go to whenever any issue related to buildings was concerned. As was mentioned, I think Professor Kandpal, you mentioned it, he brought Markle into the country, and therefore the whole issue of energy planning in any kind of an optimization framework, Professor Bansal was the person to go to. As we move ahead, I think it is also important that we remember his very seminal contributions. I remember, I was with the Bureau of Energy Efficiency. Professor Bansal chaired the Buildings Committee and came up with the revised building code, the revised ECBC, and for something, and brought people together. There was a huge tension of people who wanted very advanced standards and people who wanted them to stay as it was for competitive reasons. He brought them together and put in a two-framed approach, the first being the ambitious and the second being where is it that we go in the near term. And through that concept, he was able to bring a framework through which we brought in advanced technologies, giving in a sense a notice that 5 years from now you'll have to move to this advanced technology. Right now we are doing this, and therefore created a framework through which we were able to move ahead. I couldn't think of bringing together everything that he did, except to look at how he has influenced not only buildings, but also renewables, and also the larger energy policy of the country. And what I'd like to do is to capture the kinds of things that, in a sense, are happening now and will be our challenge in the years to come. As we move ahead, what I would like to do is to focus on first the buildings challenge, where we are today, what do we look at it, because buildings are the single largest user, or actually the second largest is industry. They're the second largest user of electricity in the country. And then on the other side, how the electricity transition is impacting energy supply. Bring them together to see where is it that we go in the future. I wanted to share a presentation. I hope it is visible now, or do I need to do anything to make it visible?
It is visible, sir.
Okay, great. So, the first point that I wanted to make was that buildings today are very different from those of yesterday. And the buildings of tomorrow will be even more different than those of yesterday. And I think whether it is capturing the kinds of passive architecture that was carried out, of which Professor Bansal himself was such a great exponent, or whether it is adding renewables. Again, he was the first person to add a solar roof. This picture shows the TERI building in Gwalpahari, built in the late 1990s, which brought in building integrated PV into the roof. All of these are moving us into a very different future as compared to what we had. We also note that because of the greater use of insulation, buildings today can afford to have more air conditioning and yet lose less energy. And we move towards what are called as net zero buildings, which is that they generate more electricity than they consume. But by far and large, the biggest difference that is happening between buildings built yesterday and buildings built today and tomorrow is that the percentage of buildings which are air conditioned, whether home buildings or commercial and industrial buildings, that fraction is increasing. Air conditioning has really taken off in this country. And if you look at how ACs have sold in the past 15 years or so, we see that the number of air conditioners has gone up. The sales has gone up from less than about 1 million pieces a year to more than 7 million pieces in the year that was just ended. And please note that despite the pandemic, the sales did not decrease. We kept the air conditioning sales as still grew at 15%. Last year in summer, if you wanted to buy a high star AC, you have to order and wait. People realized that ultimately it's costs that matter, and therefore efficiency matters, and therefore high efficiency air conditioners. Last year, if you wanted to buy a 3, 4, or 5 star AC, there was typically a 1 month waiting before you got it. What it has also meant is that the number of buildings that are air conditioned has increased. And if you look at those numbers, we have grown from less than 2.5% in 2005 to something of the order of about 7% now, 7.5%, I think it was last year. And it is expected that at this rate, it will grow to something of the order of about 12% by 2025. This is very, very fast. Remember, of course, that the vast number of buildings that India has are yet to be built. People often take a number that anywhere between half and 2/3 of the buildings that this country will see are yet to be built. And it tells you that if more and more of them are air conditioned, you can imagine the impact they would have on the electricity load. Thankfully, though, what is happening is that many of the new buildings are building in particularly photovoltaic generation, obviously other kinds of renewable generation also, but particularly photovoltaic generation of the kind that you see in this picture. This self-generation, and some buildings produce half or 1/3 as much electricity as they want, some produce 105%, and then sell the balance into the grid. So we see this across the board. But what is happening is that the number of buildings is increasing. The number of buildings with rooftop solar is increasing. Yes, the total numbers are still very small, but they are growing fast. We expect that the rooftop solar will continue, particularly as the issue of what is the price that the grid pays for solar electricity, for people who themselves generate electricity, who are both producers of electricity and consumers of electricity, prosumers as they are called. As the number of prosumers increases and as the regulations regarding the price at which this self-generated electricity is bought by the grid, as that goes towards an equilibrium where neither the person who is generating loses nor the grid loses, I think we will see an even faster growth than what we have seen till now.
Yes,
what I was talking about was the fact that we are in a position where we are looking at more and more buildings doing self-generation. Now, this is a small number, but increasing very fast. And and I'll just repeat what I said earlier, as the rules of the game change, because there's this whole discussion around them about the prosumers being paid at net metering prices, where the utility loses because they get the price, they have to pay a price which they charge to the consumer, but they get the electricity at a time when there's nobody else who wants it. On the other hand, if you take it at gross metering, then you have the problem that all the benefits are taken by the utility and none by the consumer. And possibly we are looking at something in between that as we move ahead. As that happens, we will find more and more net zero, in fact, negative energy buildings which produce more electricity than they use coming into the market. Now, what that will do is that it will completely change the hours of demand. So today the electricity grid knows that we have a demand in the afternoons in summer when air conditioners are on. We have it then in the evening as people come home, they switch on their lights and their air conditioners at home, and so in the evening you have a peak. We also have started seeing in urban areas that you start seeing a peak late into the evening. This is as household air conditioners increase. So they are now becoming more than the air conditioners at work. So you have a peak at 3 o'clock, you have a peak at 9 o'clock. And in cities like Mumbai and Delhi, the peak at 9 o'clock is higher than the peak at 3 o'clock. But now if you've got solar energy, that completely changes the time at which you will need this electricity. You won't need it during the day. So 3 o'clock peak, they won't have to meet. But at night when there's no solar energy, then everybody will want to buy from the grid. So the night demand will be even higher than it is now. This is a challenge. Let me therefore now move to the other side, to the grid. If you look at the grid, the biggest problem that they have is that they are looking at a scenario in which renewable electricity is now the cheapest electricity in the market at 1.99 rupees per kilowatt hour per unit. Solar electricity is now, there are 3 different tenders which have been found at this particular price. The price continues to decrease. What it means is that the utility also is now getting a lot of cheap electricity in the day. And what I wanted to share with you is a screen which shows that we have something of the order of about 50 gigawatts of solar electricity. Most of the electricity that is sold to the grid in terms of gigawatts, most of it is in the range of 3 rupees per unit to 1.99 rupees per unit. Yes, there is some old contracts at 7 rupees, at 9 rupees, at 18 rupees, at 25 rupees, but they're so small that they collectively don't even add up to something of the order of 400, 500 megawatts, 0.5 gigawatts. Now, 3 to 5 rupees is the price of the variable electricity from coal power stations. So coal power stations have two parts to their total cost. One is the capital cost, which is called the fixed cost. And distribution companies get into long-term agreements, long-term power purchase agreements with the coal-based power plants and pay the capital cost whether they buy the electricity or not. And then the second part is the variable cost, which is essentially the cost of coal. And they pay this price if they buy the electricity. So what we are seeing is that this price of solar electricity today is matching the variable cost of coal electricity. It's much less than the total, but it is in the same region as the variable. This is important because what it means is that if I am a distribution company and I am paying the capital costs, and then somebody comes and says, please buy the solar electricity at a price which is less than the variable price I would pay to get that electricity, I will say, okay, I will buy the solar electricity and still keep on paying the capital cost. We are now entering that region. Yes, of course, as solar comes in, as wind comes in, the hours in which the grid gets more electricity also changes. Like we discussed in buildings, same thing happens to the utility. You get a lot of solar electricity during the day. You don't get it at night when the peak happens. When all of us switch on our air conditioners at home, unfortunately, there's no sun shining at that time, and we have a problem and the grid has a problem. So where does it get today? Well, today it gets it from coal electricity. But if we move to 100% renewables, then we need to make sure that batteries are there, which help, or storage, let me say in the larger sense, is there, which helps meet this power need at the time when solar is not working. Which means that it is very important to ensure that we have adequate amount of storage in the system. During the lockdown, the Solar Energy Corporation of India had done a tender for round-the-clock electricity using renewable electricity. And Renew Power gave, which won the tender, said, I will use it using solar plus batteries. And the price that they quoted was competitive with the price of, well, round-the-clock coal electricity. Coal electricity is round-the-clock, which we would get from the power station, of the stranded power stations, not even new, but stranded power stations that already exist. This reflects the fact that it is a few years only before we come to a situation where renewables plus battery would be the cheapest form of electricity at any time of the day. And therefore, we will start seeing more and more of it coming in. This is at a time when we will need more electricity. Because yes, electricity will meet all the demands that it has today. There are lots of people who don't have electricity and have been recently connected to the grid. They will also draw more electricity. But as we move towards a zero carbon economy, we will also start seeing electricity being used in other areas like transport. We're talking a huge bit about electric vehicles, the issue of charging stations. We're also talking about electricity used in industry, where fossil fuels are used today, particularly in heating applications. except very high temperature heating applications. If all of this electricity is needed, we will then need what the Prime Minister called for, which was 450 gigawatts of renewable electricity by 2030. The grids also have to take into account the fact that the prosumers, the producers and consumers, people who have solar on their rooftop, the prosumers are increasing and therefore are putting in more electricity during the daytime hours. So from the view of the electricity company, they are today getting a lot of cheap solar electricity when the sun is shining during the day. And hopefully what everybody hopes for is that day after tomorrow, we will get round the clock renewable electricity, which is cheaper, and therefore we will be able to supply that electricity. But the issue of prosumers putting in electricity means that that electricity may not need to be generated by the grid itself, but could come from the users. Now, we have talked about electricity. I would like to take a short deviation and talk also something about another part of the energy transition. I talked of the fact that we will see a lot of urban transport using electricity. I talked of the fact that we will see a lot of industry using electricity, especially for heating purposes, except in high temperature heating. What about those high temperature heating purposes? What about the long distance transport? We see that being met by hydrogen. Hydrogen being generated by the splitting of water using renewable electricity. So note the irony of the transformation. Today, we have fossil fuels as the basic energy building blocks, say gas, which is then reformed to produce hydrogen. So hydrogen comes from a fossil fuel. Tomorrow, we are talking of renewables being the basic energy building block, and hydrogen comes from the splitting of water using that renewable electricity. We therefore are also looking at hydrogen fuel cell applications. And we may find that in many buildings, particularly those buildings which have a lot either of heating or cooling, if they can use absorption technology, cases where hydrogen and fuel cells may be competitive with the direct electric uses. But that's going to be very building specific. It will depend on the size, it will depend on where it is, it will depend on the hydrogen network, the supply network. But I just thought that I would mention it, that we are looking at a future in which we are looking at renewable electricity, we are looking at hydrogen, and to some amount biomass fuels as forming the basis of the energy system of tomorrow. Let me now come to bringing all of this together. You know, I actually believe that buildings are the key to the energy transition. Why? Well, the first point is that increasing energy efficiency in buildings, using insulation materials, increasing the efficiency of appliances in the buildings, air conditioners, but also refrigerators and other devices, they create the ability to directly use renewable electricity from distributed generation. Now, what this means is you have higher efficiency on the one side and you have renewable use on the other side. This means that we are looking at a new generation of technologies being developed so that they meet these kinds of needs. It has a huge impact on the availability of obviously technologies, but also of the larger ecosystem within this, whether you're talking of supply companies, whether you're talking of engineers who design, whether you're talking of the kinds of methodologies that would be used in order to balance these demands. The second is the issue of prosumers that I talked about. Prosumers, that's consumers and producers together, will determine the extent and acceptability of distributed renewable energy generation. And you can imagine that as far as regulations of tomorrow are concerned, if we don't enable prosumers, we have a huge problem, because people will put up renewables on their rooftops because of the integrity, the autonomy that it gives them. However, when I'm producing more electricity than I need, I will want to sell it to somebody else. If the grid doesn't buy it, I'll want to sell it to my neighbor. The so-called peer-to-peer networks, as they are called now. In other words, the way the rules change, so to me, this is going to be the key area for development as far as regulations are concerned. How do we capture prosumer interests in the regulatory framework? The third issue, I think, how buildings are going to affect the energy transition is the fact that where do you store this energy? You can obviously feed it into the grid, but from an energy point of view or from an economic point of view, it is best if it is stored as close as possible. Now, one can very well argue that for a very large number of houses in India, which have inverters in them, and which have therefore a large amount of battery storage already available, we could use that. But that's way inadequate when we look at the total numbers in terms of the rooftop solar that can be produced. Where can this go? So we thought of various options, and one of the options which I will want to share with you is something that we are working with the Calcutta Electricity Company. And this is looking at setting up storage batteries downstream of electric transformers, distribution transformers. Why? Because in urban areas, it is very difficult for the distribution company to find space where they can put up an expansion transformer. So they said, okay, we'll try this. We'll put up a battery downstream of the transformer, which is charged when the transformer is not working at full load. And when the transformer is working at full load, the battery provides the electricity that is needed by the users who are connected to that distribution transformer. But tomorrow what can happen is that instead of being charged by the grid, these are charged by the rooftop solar electricity that is produced. Because they're downstream of the transformer, in a sense, they are the prosumer's extended storage, but in the public domain. Now, this obviously implies that we need the technologies, whether it is control technology, whether it is sharing technology, whether it is pricing technology, which allows the splitting of the electric power that goes in, the electric power that goes out. That's on the one side, but on the other side, that these batteries are charged, and therefore the charging levels, both from the view of the prosumers as well as from the view of the distribution transformer. And the last point that I wanted to make is that buildings have a huge multiplicative effect. If you look at buildings, each one of us lives in a building. It could be a professionally built building. It could be something that you did yourself. It could be something that is made of mud. But each one of us lives in a building. And consequently, the kind of ecosystem that is needed, whether it is of a mason, whether it is of an electrician, whether it is of a plumber, it is something that goes right through society. And therefore, changes that occur in the buildings have huge impact on economies as a whole. I'll give you one example. When Delhi was being built in the early part of the 20th century, 1911 is when it moved. A large amount of construction occurred in the 1920s and 1930s. When Delhi was being built, the pre-stressed roof came in, the flat roof. Before that, the roofs used to be curved. There was typically an iron bar reinforcement which was visible. It is still seen in many of the older buildings that you will see around. But as pre-stressed concrete roofs came in, you suddenly started seeing them move across the country. How did they move? The masons moved. The second thing that we started seeing was that the kind of reinforcement changed. And we started seeing the kind of Tor steel that you use for reinforcement. Now, this meant that the steel companies needed to change their product. It meant that design engineers changed the methodologies. The standards organization changed the methodologies by which they work. It also meant that now you could have electric cables going through, whereas earlier that was not possible. So in all, we see that any change that occurs in buildings leads to a large scale change, not only in the building itself, but in the larger ecosystem. And I believe that the buildings are now ready. They are key to the energy transition. I want to thank each one of you for giving me the time. I particularly want to thank Dr. Bansal's students, with so many of whom I've had the good fortune of working closely, whether it is Jyotirmoy, whether it is Vishal, whether it is Ranjan, whether it is Inderjeet. All of these are people who I've had the pleasure of working with. I greatly commend your initiative to remember Dr. Bansal and what he brought to this country. And I hope that this little contribution to his memory would also play a part in how he is remembered in the future. I thank you for your attention.
Thank you very much, sir, for giving us a 360 degrees view of this energy scenario. I think we have some questions that have come privately to me, and if you permit, can I take 2 or 3 of them?
Yes, please.
So, sir, one question is about the prosumer aspect, because the question is related to the dilemma between, or the shifting between, net metering and gross metering policy. In some states, the policy is taking a shift from net metering to gross metering. So, will it still continue to attract rooftop solars, and would it still keep the economics attractive for the prosumers the same way as it used to be for the net metering?
Jyotirmoy, the answer to me is fairly clear. You want a system in which all players benefit. And in the net metering system, the consumer benefits, the grid loses. In the gross metering system, the grid wins, the producer loses. Neither of these are viable on their own. So we have to be somewhere in between. I mean, for the lack of a better methodology, I would say split it right down the middle and say that the regulation should be that the price at which electricity is bought is half of the price between the net metering and the gross metering. Now, some of you will come up, I'm sure, with better methodologies for splitting the difference so that the risks and benefits to the prosumer and to the grid are more equitably distributed. But my feeling is that unless we go into some kind of a splitting of benefits, this will not go ahead. Thank you.
Okay. So the other question is related to the load curves. You also shared the load curve of Delhi and other places. So the question is related to impact of e-mobility mission on load curve. What is the possible impact of e-mobility mission on the load curves?
So, Jyotirmoy, the quick answer to this is we don't know. Well, we do know what will be the total energy demand, but at what time of the day it will happen, we don't know. We did a survey of two-wheelers, and it was very interesting. People who had electric two-wheelers, people who did not have electric two-wheelers said that they were not buying because they did not see a large charging infrastructure. But people who had electric two-wheelers said that they charged them at home and they charged them at night. So you are seeing a further increase in the curve. But if you have a fixed charging space, we could, if it becomes very large, we could say that if you do it at 2 o'clock at night, you would have a lower price, and devices will come which will help you fix it so that it comes on only at 2 o'clock at night. So it's something that's manageable. Similarly, when we looked at buses, we found that the buses operate during the day. They come back to the depot largely at night. And again, this is a curve that occurs. This is a charging demand that occurs at night. Cars, we weren't clear because people said that they could charge it at office if it was available. So one of the key challenges, whether no matter which kind of vehicle you're looking at, one of the key challenges is how do I make a charging point available? If I live in a flat, I don't have a fixed parking space. So would there be a number of holes, electric sockets where I could plug it in? Well, how will they know you have to charge me? Or will I have some kind of a card that I put in? And then if the number of vehicles that need to be charged are more than the number of points, who removes the car once it is charged, say at 2 o'clock at night? So there are a lot of logistics issues that still need to be worked out as far as charging is concerned, which have an impact on the load curve. But let me first say that even if we go in for 100% vehicles being electric, 100% being electric, the addition to the demand to the grid is only 20 gigawatts. And I say only 20 gigawatts because we have a system which is 350 gigawatts, but the maximum electricity we have ever used is approximately, it's less than 180 gigawatts. So there's a lot of excess capacity available. Yes, I agree that some of this capacity is renewables, some of this capacity is gas and so on, and so is not always available. But even then, there's a substantial amount of excess capacity that's available. So meeting the energy demand is not a big deal. It is it is when you need it that's going to be the key problem.
Sir, a last question which has come to me is regarding the time of day tariff. Why is it not so popular in India? The question is this.
Okay. Note that only 15 years ago, even in the city of Delhi, we did not, the reliability of electricity supply was relatively poor. We did not know when electricity was going to be there, when it was not going to be there. This is still true certainly across the rural part of the country. It is also true in many urban areas. There are some urban areas like Agra, which have 23 hours and 50 minutes of supply in a year. Now, what the consumer says is that you move me to a time of day tariff, and the tariff is cheaper at some point. At that point, you don't provide electricity. What happens? Then either I'm forced into paying more for electricity and using it at a time when it is available, or waiting for it for a particular moment of time when it is cheaper, and then I don't get it. So till the public perception of reliability is completely built up, we will have issues in moving to time of the day tariff. Having said that, there are already many states where for industrial uses, and in some states also for commercial uses, where time of the day tariffs are already in place, but they're not in place anywhere for residential uses.
Kandpal sir or Professor Subramanian, if you want to ask one or two crisp questions to Dr. Mathur.
Yeah, I had just a couple of queries, Jyotirmay. One is that, Dr. Mathur, what do you think, how long renewables will have to depend upon the incentives provided by the local, state or central government? I mean, renewables will ever come out of this or not?
My own feeling is we should start bringing them out of all incentives now. The price of renewables at the generating point already is at a historic low and will keep going down. The biggest incentives, there are two incentives that are being offered to renewables. The first is the must-run status, and the second is the interstate surcharge for long distance transmission, they don't bear any costs. The third and hidden incentive subsidy is the need to carry capacity with us so that when they are not working, so for example at night when solar is not available, something else comes on. So we have to keep say for example coal capacity, which is only used when solar is not there. So for the day when it is not used, it's an additional cost that is being put in place.
Mhm.
Having said all of this, even today, and this will only increase over time, even today, the total cost of electricity, including everything, whether from renewables or coal, is more or less the same. It is higher for renewables because battery costs are higher, but day after tomorrow, battery costs become less, these two will become equal. But the big difference is that the capital cost for renewables and batteries is higher, and the capital cost for coal-based plants is lower. And on the flip side, the marginal cost or the variable cost for coal is higher, and the variable cost for solar and batteries is lower. So the key issue in managing the subsidy is really to move towards a system which allows for the relative costing of capital and the relative costing of variable costs. I think moving regulation to that direction would move away all the subsidies that you're talking about, and we should start on it today.
One small query again, Mathur sahab, that is this, the cost reduction in photovoltaics has, it has been in last 10 years, a very drastic reduction in cost, right? But then now, the soft portion of the cost, overall cost, whether it is designing, whether it is installation, whether it is, that part, the cost reduction is not going to happen as much. So do you see that even the PV electricity cost, the generation cost, not the grid stability, other aspects, are going to, plateau, will stabilize at a certain level? Or do you still further see that there will be, I mean, I'm not talking of the new generation solar cells, but with the crystalline solar cell, do you think that the cost will now, we will be stable somewhere besides the financing gimmicks which bring down the cost?
Kandpal sahab, the cost of renewables, we have found it useful to break it into three parts. One is the cost of the panels and the hardware. And that is where your question is addressed. The second is the cost of installation, and the third is the cost of capital. Because solar is more capital intensive, the cost of capital, the interest rate matters a huge bit, and therefore any way in which we are able to reduce costs matters greatly. As far as installation costs are concerned, we are still seeing a decrease. In fact, the single largest installer in the world is an Indian company, a Shapoorji Pallonji company called Sterling and Wilson, who is now setting up plants across the world. They are still seeing reductions in prices occur, though I must say that these prices, well, because of many reasons. One is economies of scale, the other is using materials which are new, etc. On the issue of technology, my own belief is that on crystalline cells, we are now looking at a plateauing. But as you yourself mentioned, we have got new generations of chemistries and deposition techniques that are still, which are yet to come into the market. Something, I'll give you a very simple example. In the last two tenders, we saw, for example, that bifacials have started appearing in the tenders. So they are enhancing the efficiency, and what we thought, I mean, this is not absolutely sure, but looking at we thought that people were using lower efficiency cells, but by using them, by having mirrors which allow their use both during when you have direct sunlight as well when you have sunlight on the other side, you're therefore increasing the overall efficiency while the individual efficiency is falling. So what we are seeing is these kinds of interventions also occurring even before the newer technologies come in. There's something else that we are seeing. We are seeing that, for example, their total cost of cells, no matter how you do it, is changing. Technologies today look at silica, going to wafers, going to cells, going to modules. We are seeing technologies which are going directly from silica to cells. So you don't go through the wafer, cell, you don't go through the intermediate steps. This dramatically reduces cost, and not by one or two things. I mean, we are talking of a 25% reduction. We are seeing ways in which the deposition techniques, instead of being film deposition, instead of being chemical deposition, we are moving towards film deposition, like you do inkjet on a paper. That is reducing cost. So we are seeing all kinds of processes occurring which reduce the overall cost of generation. So my feeling is we have not stabilized at this price. I think the prices will continue to fall.
Yeah, thank you. Thank you.
Can I ask something? Yes, sir. Thank you for your presentation, sir. Our country is targeting 450 gigawatts using renewable energy. If it so happen in future completely from renewable energy for our country, there is no need of coal-based power plant, etc.
Subramanian Saab, this is a very, very, very difficult question. On Friday, we had a huge and very heated debate on this. And this ultimately really depends on one thing. It is the speed at which the cost of storage comes down. If the cost of storage, if the cost of solar plus storage does not meet the cost of coal electricity by 2025 at a large scale, we will see coal coming in to meet the balanced demand. And we could have as much as 4,000 megawatts, 4 gigawatts of new coal-based capacity, which may be needed before 2030. This could be replaced by solar plus batteries if the price of batteries falls fast. So unfortunately, this is something on which I cannot give an answer. As I said, this is a matter of heated discussion.
Okay, thank you. So another one, the electric vehicle and hydrogen fuel cell. Electricity to electric vehicle versus electricity to hydrogen, then fuel cell vehicle. Which would be the economically possible in near future?
So one of my colleagues he looked at hydrogen. Now, if you look at pure economics, there is almost no transport application where electric straight is not the best solution. It is always the best solution, except if you've got very, very long distance. Now, the problem that comes is not an energy economics problem, but a logistics problem. Because what it would mean is I am carrying a lot of batteries. So it reduces, if I have a truck, it reduces the payload that I can carry. That's one part. If I don't carry too many batteries, then I have to get charged every few hours, every few hundred kilometers. That means time. The third is, if I have got petrol pumps which are being somehow supplied with petrol, and tomorrow if they can somehow be supplied with hydrogen, then I can use the existing infrastructure. So to answer your question, I think the answer will come not from the energy and economic side, but from the logistics side.
Yeah, so thank you, sir. Thank you so much for your query.
Thank you.
I
Thank
think
you so much.
we had a very good discussion session, sir, and thank you very much, Kandpal sir and Subramanian sir, for making it more interactive. We had 74 attendees in this session, right from India to Germany. We have Professor Wagner, Professor Frank Spitte, and Ms. Melis. And then we also had Dr. Mahavir Bhandari and Pooja Shalu Shweta, daughters of Professor Bansal, as I said in the beginning, attending this. So this was really truly a international event, as it befitted to the stature of Professor N.K. Bansal. So I would request Dr. Vishal Garg to kindly come up with the vote of thanks and close the session, please.
Thank you. Hello, everyone. On behalf of the organizing committee, I thank you all for your presence here today. I thank Dr. Ajay Mathur, Director General TERI, for his insights and sharing his knowledge and inspiring us. We are fortunate to have you here today, sir, especially this being Sunday and such a short notice. Thanks a lot for accepting our request. I'm also grateful to Professor Subramanian and Professor Kandpal for their presence, and remembering Professor N.K. Bansal for his contributions in the area of building energy efficiency. Thank you, Professor Kandpal, for introducing today's speaker, Dr. Ajay Mathur. I thank the team in the organization, Dr. Rajan Rawal, Dr. Inderjeet Singh, Vaibhav Khare, and other members of IBPSA-India who participated and made this event possible. Most of us who had pleasure of working with Professor N.K. Bansal know how ably he conducted the academic and research work. He was our mentor and always guided us. So our heartfelt thanks again to all of you for participating and helping us pay us our respects to our beloved Professor N.K. Bansal. Thank you.
Thank you very much. With this, we come to the closure of this first Professor N.K. Bansal Memorial Lecture. Thank you very much again.